Hello everybody, here's your ratio notes part 2. We are on page 4 of the notes and we're going to start with ratios, rates with tables and graphs. Students in Mr. Webster's science class are doing an experiment that requires 150 milliliters of distilled water for every 3 milliliters of solvent. So what we're comparing is the solvent to the distilled water. Now they said 3 milliliters of solvent is going to be 150 milliliters of distilled water. So we need to fill in the table. What would 2 be? What would 3.5 be? How much solvent is needed for 300 milliliters of distilled water? Well, looking at the 3 to the 2, I can't drop from 3 to 2 multiplicatively very well. I cannot take 3 divided by something and get to 2 very easily. But what I can do is go find my unit rate. If 3 is 150, then 1 would be 50. Divide by 3, divide by 3. So if 1 is 50, that means double that. 2 would be 100. The next one wants 3.5. It would be nice to know how much 1/2 is. So I'm going to come back over here. If 1 is 50, then I cut that in half. 50 would get cut in half to be 25. Now here's a neat little trick you can do with tables. If I'm trying to find 3.5, I could do the amount for 3, 150, plus the amount for half, 25, and get 175. And they already gave us 4 is 200, which makes sense because another half would give me 4, and another half here is 25. Also, that 4 and 200 reduce down to 2 and 100 and 1 and 50. Okay, now I need 300. I'm going to look at a 200 plus a 100, which means I would take 4 plus 2, and that gives me 6. Or I could look at it as 150 times 2 gives me 300, and 3 times 2 gives me 6. Or I could say from 100 to 300, that would be times 3, and 2 times 3 is 6. Or I could do 50 times 6 is 300, and 1 times 6 is 6. There's always various ways you can fill in information on the table based on what you're seeing. Okay, number 1. What is the multiplicative relationship that compares the distilled water and the solvent? Well, as I look at the distilled water, I see that it's more. In fact, it's 50 times more, so that's going to be my description. Distilled water, I'm going to say DW for distilled water, is 50 times the solvent. Okay, and the unit rate for the scenario when the solvent is 1 milliliter would be 1 milliliter of solvent has 50 milliliters of distilled water. I'll call it DW. Are the ratios represented in the table equivalent? Yes. And you could say a couple of different things. They have the same multiplicative, times 50, times 50, times 50, all the way through. Same multiplicative. And you can also say that all of these ratios can reduce down to 1 over 50. Even 1/2 can build up to 1 over 50. So yes, they are equivalent. Okay, number 4. How can we use the table to find the amount of distilled water for 6.5 milliliters of solvent? Well, 6.5 I would put out here, extend the table. And then to find out how much distilled water that is, there's several different ways. I could go from 1/2 to 6.5. I could take how much it is for 1 and times it by 6.5 and 50 times 6.5 and get my answer. But what I like to do, this is me, I like to take how much is it for 6, 300, how much is it for 1/2, 25, and combine them, 325. So there are many, many various ways that you could answer this question. You decide which works best for you. Okay, going to a graph. Graph the values from the table above. use solvent for the X right here and distilled water for the Y up here. And what I notice automatically is this is where 0 is, and then there's a blank 2, blank 4. So I'm going to go ahead and fill in that's a 1, 2, 3, there's 4, 5, and 6. That's for my information. And then coming up, I have a blank and then 100. So this should be in between 50, 150, 250, 300. That helps me read the graph a little bit better. Now from the table up here, I know that for every 1 solvent, I need 50 milliliters of water. So I'm going to put a dot here. And then 2 was 100, and 3 was 150. And 3.5 would be right between 3 and 4, and that equals 175, which is between 150 and 200. My dot would go in the middle of that square. Then 4 goes up to 200, and then 6, they skipped all the way to 6, goes up to 300. Now, does it make sense to connect the points on this graph? Actually, yes, it does. Because can I have between 0 and 1 milliliter of solvent? Yes, I can have fractional amounts. And I can have fractional amounts between 0 and 50 of distilled water. So can we connect the line? Yes. Why? Because there can be fractions. Okay, I'm going to go ahead and connect my line as best as I can without a ruler. There we go. Manual says that 275 for the distilled water, you need 5.5 milliliters for the solvent. Is he correct? Well, what I would personally do is go to 275 on the distilled water. That is up here. And then go to 5.5 on the solvent, which is right here. And I'm going to draw this line until I reach my original trend line, and then bring this down. Does it line up? Yes. So I'm going to say yes. The ordered pair matches the line. And what I mean by ordered pair, that means 5.5 on the X and 275 on the Y matches the line. What I mean by that, it lands right here on that line, just like all the others. All right, number 7. Does the order pair 1.5 and 125 make sense for this scenario? Well, let's see. I'm going to go to 1.5 on the X, follow it up to my trend line, and bring it back. That gives me between 50 and 100, which is 75. So for this, does the order pair make sense? I'm going to say no. What it should be is 1.5, 75, or if I go to the 125, which would be right here, follow it down, that would be 2.5 on the X and 125 on the Y. Now, does the graph show that how does the graph show this is a multiplicative relationship? Well, as we all know, it goes through the origin, which is 0, 0 on the graph. So because if I have no solvent, that means I'm not going to need any water. Okay, next page. My favorite, proportions. Proportion is an equation that shows two equivalent ratios. It looks like part of a table. Just like table, labels are important. Any multiplicative relationship can also be called a proportional relationship. Let's fill in that blank. Okay. Now what they mean, setting up a proportion is basically keeping everything nice and organized. Like if I have trucks to boxes, or if I put the boxes on top and the trucks on the bottom, see how they're nicely lined out? That's a yeah. Or I could do a vertical table, trucks, trucks, box, box, or flip them around, boxes and trucks, still very organized, yeah. But if my trucks are crisscrossed and my boxes are crisscrossed, that is not organized. That's what we call a non-example, or poo-poo, yeah, yeah, poo-poo. So whenever they want this not. They're looking for the non-example. Okay, this one here says 10 apples are needed to make 2 pies. Which proportion cannot be used to determine the number of apples A needed for 6 pies? Well, first I see that 2 and 6 are both pies, so they should be lined up. The 2 and the 6, the 2 and the 6, 2 and the 6, 2 and the 6. Looks like based on just the pies, everything is a yeah. Okay, now let's look at this 10 apples. Well, the 10 and the apples are all lined up, of course, but the 10 apples have to go with the 2 pies. See, 10 apples don't make 6 pies, 10 apples make 2. So the 10 and the 2 should be lined up. Yeah, poo-poo. Yeah, yeah. So it looks like B is our answer. Everything else was set up correctly in one form or the other, but B got crisscrossed. So that is the one that's not right. Okay. Going down to number 1, we are going to set up a table. We're going to label, we're going to show scale factors, and we're going to solve. During the first 9 weeks of school, Leah took 4 math tests. At this rate, how many math tests will Leah take in 36 weeks of the school year? So setting up a proportion table, you can either use 2 equal fractions like that, but I also build a table like this. Then I'm looking for the 2 things I'm comparing, which looks like we got weeks and we have tests. So I'll call one of them weeks and one of them tests. And it says in 9 weeks she took 4 tests. So the question is, at this rate, how many tests will she take in 36 weeks? So then I got to look for my scale factor. 9 can't go to 4 very easily, so I'm going to look sideways. 9 can go to 36 by doing a times 4. And 4 times 4 would equal 16. She'll take 16 tests in the 36-week school year. Right. Number 2. The machine a candy factory produces 5 pounds of candy every 3 minutes. So let me build my table. I'm comparing pounds to minutes, and I've got 5 pounds every 3 minutes. At this rate, how long will it take for the machine to make 45 pounds of candy? Well, the pounds have to go with the pounds, so 45 is up here. I can also set this table up vertically. Pounds, machine, 5, 3, and the 45 would go here with the pounds. We're trying to find out, not machines, minutes. How many minutes it will take for the machine to make that 45 pounds of candy. Now, I can't go to 5 to 3 easily, but I can go 5 to 45 by doing a times 9. So 3 times 9 is 27. It will take 27 minutes to make 45 pounds of candy, and it'll take me about 5 minutes to eat them. Haha. Okay, so even with the horizontal table, you can see that 5 goes to 45 with a times 9, and 3 times 9 is 27. Okay, last page. Head to the back. The top of this is just some strategies and a checklist we created. How to make sure you're setting it up right. Make a proportion table. Use your scale factors either within the 2 quantities or between the different groups. And also sometimes it helps to find the unit rate, how much one would be, and then scale up or scale down as needed. Okay, let's try these last few and then we'll be done. It says that a diver made 15 dives in 3 hours. So let me make my table. I'm doing dives, I'm doing hours. I have 15 dives in 3 hours while collecting samples from a coral reef. At this rate, how many dives would the diver make in 5 hours? So I'm going to go from 3 hours to 5 hours. Now, I don't see 3 going to 5 very easily, but 3 can go to 15. My scale factor I see there from 3 to 15 is a times 5. So I would do 5 times 5, and my final answer would be 25. A unit rate would be helpful on this one as well. You can solve it like this. If you take 3 hours to do 15 dives, then in 1 hour, which would be divided by 3, 15 divided by 3, 5 dives. That's 5 dives per hour and 25 dives in 5 hours. I would scale it up with a times 5 and scale this up with a times 5 as well. So either way is fine. Number 2, the ratio of boys to girls in a school orchestra was 3 to 5. So 3 being the boys, 5 being the girls. Based on this ratio, how many boys are in the orchestra if there's 48 total students? This kind of ratio is going to have 3 columns. You have boys, which are 3, girls, which are 5, and total, 3 and 5, gives us 8. Then our total is going to go from 8 to 48. So I can see this scale factor quickly. 8 times 6 is 48. So 5 times 6 is 30, and 3 times 6 is 18. So the question asked how many boys? That would be 18 boys out of 48 total students. So be aware when they combine, you're going to have to make a third column. All right, last one. Woohoo! A window washer cleaned 38 windows in 2 hours. So make my table. Windows, hours, 38, and 2. At this rate, how many windows can he clean in 7 hours? Okay. Now, I can't go from 2 to 7 very easily, but I know that 2 times 19 is 38, and 7 times 19 will give me the answer. However, I can also go to a unit rate, 1. To get from 2 hours to 1 hour, you cut it in half. 38 cut in half, 19. So that's 19 windows per hour. And then I can scale up to 7 hours times 7. And just like I thought before, I would take 19 times 7 and get my answer. So let's work that out. 9 times 7 is 63. Carry the 6. 7 plus 6 is 13. So that's 133 windows they can wash in 7 hours. Okay, I hope this was helpful. I hope you do well. Take care. Good night.